Hi there, welcome to this lesson where you're going to learn about creating an Amazon S3 bucket where you can store your files on the cloud. So let's start with this. Here just go to the services and browse over storage service, and here the first service is Amazon S3. So S3 is short form of simple storage service. That's a block storage, and here you can create a bucket. So what is a bucket? Bucket is a logical folder or directory where you keep all your content. So bucket is the abstract form of it's an abstract logical entity. So you can create multiple buckets on Amazon S3. Just provide with a name. You have to select an Amazon region where this bucket will be stored. Your data will be stored. So you can choose from various Amazon cloud regions like Virginia and other places. And next, you may choose to block all kind of public access to this bucket directory, or you can retain some access. So if you want your bucket to be available on the public domains, it can be made available. Otherwise, you want to block, you can block it. And you can only access internally with your own cloud account. And then you can select the encryption or advanced setting. You can choose to have an object lock, and once you're done, just hit the create bucket and it will be available to you. And here we can find there are multiple buckets that's already created, and here we have created this Athena data 101, and this is the bucket for here. And once you open the bucket, you got various properties, the file permissions to access this thing. You got various matrices. You can select this thing, and you can anytime edit some settings like public access. You can customize it later on. If you customize, you have to confirm, otherwise just leave it here. Maybe after you have created your bucket, you want it to be available by public domain, you can just set it there. You can have the cross origin resource sharing enabled. You can find a metrics here for performance indicators and other things. You can select the access points, and here just go to the objects if you want to create other folders or subfolders and upload different files here. So if you want to store some files on the Amazon cloud, S3 is the way to go. Even when you want to create an integrated application that requires some sort of data, it could be linked with S3. Say if you want to host a website and you have a database, you can upload your data set on S3 bucket. You can add multiple files as well that would contain the images, dataset, text, other informations, PDFs and other things. And then you can use this Amazon resource name or S3 ARN, and it could be connected to other services on the cloud. Like Glue, you can create a crawler with Amazon Glue, and Athena, you can connect it to Redshift or DynamoDB databases and other places as well, other services. It could be used with a Lambda as a trigger and other things. Here we have uploaded this file, that's CSV format, and we got this destination link that is S3, and here we got this directory for this thing. And here you got multiple kind of storage classes that you can choose. If you want to have access your data very frequently, you can choose the standard, or if you want your data for archival purpose, you can have the glacier. And for the moderate levels, you can have these things. Say for example, if you want your website data to be available multiple times in a single day from across the globe, it is very frequently accessed, then you can put it with the standard function. And if you want it just for the record keeping, you can keep it for the glacier. So if your data is kept in the glacier, read write permission to that bucket will be very minimal, and you cannot edit it for certain parameters, and it would be safe. It would be considered as a vault, and you can create multiple S3 buckets. So it is one of the core services on AWS, and it is very widely used with other cloud services. So once you are on the AWS dashboard, you can customize your bucket and go to actions and find various options. So try to create your own S3 bucket, keep learning and keep moving ahead. Hi, welcome back friends. Here in this lesson, you're going to learn about creating a crawler in Amazon Glue. So let's start with this. So what is a crawler? Crawler is a kind of job that is defined in Amazon Glue. It crawls through the databases and buckets that are stored in Amazon S3 or other storage forms, and it will create a table in Amazon Glue. It have the same schema as the file that is stored, and after it has created a table in Glue, you can perform various operations such as ETL operations, extract, transform, load using SQL queries on this table. So just go to the Amazon Glue service. You can search the AWS dashboard and you would find it here. And just go to the crawler to create a new crawler. On the left hand side, you will find various stepwise options that we have to perform in order to create a crawler. So first we need to provide the name for this new crawler. So this crawler could be connected to various kind of data sources in order to produce a table. So it will be very handy thing. Say if you have your data stored in form of some CSV files, you could have thousands of CSV files or Excel files, and just they are kept in the S3 bucket, and you want to create a database based on those data. You could just create a crawler, or you can create multiple crawlers. It works as a web crawler, but it's not a web crawler. It just crawls over the data source that you provide on the cloud. So you can have source type. It could have a data source, or it could be used based on existing data catalog table. You can connect multiple data sources like S3, not just S3. You could connect DynamoDB as well. You could connect JDBC. You could have a MongoDB and other options. Then you can define the connection type. Like you could have a connection for Amazon VPC, virtual private cloud, and you could have this thing. So when you scroll over there, you would find a VPC. Currently we don't need any VPC, so we'll let it default. Then if you choose the S3, you have to provide the path for your S3 bucket. If you can select a specific file, it will be better. Otherwise, you can also select a folder as well. If you want to provide for DynamoDB, you have to select the folder for DynamoDB as well for the table. Then you can have the path. This S3 path is stored. You can find this is a CSV file. If you want to scroll through multiple files, you can repeat this step, and it could read various kind of files, not just CSV, text files or other files as well. So it will fetch the schema. If it is in either in tabular format, any CSV or Excel, it will find the schema, the column names, rows, and data types it will detect. And you can also provide some exclude patterns if you want to keep them excluded. Once you are done with this thing, just hit the next option if you want to configure other things as well. So you can have, if you want to add another data source, you can press yes and provide more data sources. It could scroll through multiple data sources, or if you want to keep them separate, you can create multiple crawlers as well. Then you have to choose an IAM role, identity and access management, in order to access your S3 bucket on storage. So Amazon Cloud implements various kinds of security parameters. So even if you are using a single AWS account and you have got multiple services, if you want to access one service from a different service, like here we are going to access S3 using Glue, so it requires some kind of authentication or permission to access it. You can do so for different accounts otherwise, and you have to define a IAM role, identity and access management. So you can have this thing. Once you have defined, then you can define the frequency for this crawler to be scheduled. It could run on weekdays. It could have the weekends. You can define a range for date. You can define the start time or end time, and so on. So if you want your crawler to span only one time, you can have custom range, or if you want to be let it be active for a long time, you can also provide a range. You can also select a day of the month, various kinds of parameters. You can select a time and filter. And once you are done scheduling this crawler, hit the next options, and you're ready to create a crawler. on AWS. So try to create your own crawler on AWS connected with DynamoDB or S3 storage. Keep learning and keep moving ahead. Hey, welcome back, friend. Now moving forward with our crawler, we have customized our crawler. We have created a crawler, set its frequency to run on demand. We have chosen the IAM role, added connection, the data source, and much more. So once you have provided the data source, the authentication permission, next step is to add a database. You can create a final database where all the information that the crawler has gone through could be stored. So you could just provide the name. We are using the same notation as we used for S3 bucket name for Athena, and here just provide the database name. You can set various parameters for this new database, like you can set a grouping behavior for S3 data. You could configure various options if you want to have some advanced control. You can also set the resource link name. You could have the shared database suggestions, the shared database, and other informations. If you're just beginning, just provide a database name and that's it. You don't need to provide these optional parameters, and just hit next to create your crawler's output database. So everything that a crawler is spanned through would be stored in here following the same schema. You could have create a single schema or have multiple schema. You could configure various options like other things. If you want to have this advanced options in configured here, like crawler schema that it detects, you could reflect it in here. Otherwise, just keep things in the default, and once you are done, you can go through all the configurations that you done, and if you want to edit, just go refer back to that step that you want to change. So like if you want to change the frequency from run on demand to hourly or daily basis, you can change it, and if you're sure, just create it. So here we got our first crawler in here and is currently ready. The status is showing ready. We can go to the action to perform various things. You can edit the crawler, you can delete the crawler, you could have various things in here, and just click the name of the crawler to find various options in here. After you have created a crawler, you have scheduled, and it will automatically creating this data source. If you want to start it just after creating, you can schedule a date time just next to whenever you want. You can refer into this thing, and if you want to stop the crawler, you can stop. If you want to run it, you can change it to run. So this is how you create a crawler in AWS Glue connected to S3. You can use JDBC, MongoDB, DynamoDB, and other data sources as well. It will allow you to create a table following the same schema. Keep learning and keep moving ahead. Hey, welcome back, friend. Here in this lesson, you're going to learn about customizing a schema for a newly created database on AWS Glue. You could also find details about the table and database here, and you will also learn about log analysis using AWS CloudWatch. So let's start with this. So we have created a crawler that has spanned through the S3 storage, and it has created a table and database. So we can find details about this table and view properties. You can also find the schema for this table, the name of the columns, data type, and we are able to customize it. Just go to edit table and you would find various properties that can be edited. So you can set a key value pairs, you can change the properties type, you can rename them, you can customize them. You can view the properties that will be appear in the JSON format. So if you want to customize anything, you could. You could also add various columns, rows in this table as well. It feels just like a database, and if you want to edit the schema, you can edit. So here you would be able to change the data type for a particular column. Say if you want to change the schema for order quantity, we can change it from string to binary to date to integer, float, or other formats as well. We can have the time stamp. You could use this change schema option in order to precisely customize your data set. Say if it automatically detects something as a string, but it used to be a timestamp or it could be a number, you can change it afterwards if you want to treat it as a different number. Okay, so here it is. You can customize almost every data type in here, but sometimes it may show some error. We have successfully changed the data type for order date from string to date, and it could be considered in there. And once you're done, just hit save and you can update it. So this is how you change the schema type of the newly created database. You could create multiple crawlers that can create various databases and tables, and you can go through them one by one and change the schema. So changing the schema would allow you to change the database type, so you don't need to go into the each individual fields and cell values. And if you want to fetch the log details of any operation that is performed on this table and database, you can go through the CloudWatch where you can monitor the logs. CloudWatch is very important AWS service that allows you to audit and create alarms, find log insights, various metrics and events as well. So just go to the log groups and here we can find the AWS Glue crawler application. So we have created a crawler in AWS Glue and it will find the insights. So any operation that is performed in here, it will be reflected. If you create a new column, if you change the schema, everything is shown here. So once you go through the log events, everything is saved with a timestamp and the entry for an operation that is performed. This is very useful for if you are working on with a team on some project with a corporation or organization. uh, if there is some error or some trouble, you can refer back to the CloudWatch, find the log entry, who was the admin at that point of time, where some error occurred, where there's some issues. You can resolve the issues by what operations performed. So it would be used for troubleshooting if there is an error. It could be used for auditing purpose, what operations are performed. It keeps everyone accountable on AWS. So this is very important service. You can go through the actions and find various informations in here. You can export a report on S3 bucket and it will create this thing. You could also have some filters. You can also delete the log, but log is very important and it is a text information, so it's better not to delete it. Here we got only one log stream because we have this one crawler. If you have multiple crawlers, we'll find various log streams. So AWS CloudWatch is useful with other services. It's not just useful in the Glue or Athena. It could be used for DynamoDB, Lambda, EC2, any service on the cloud to keep track of what operations are being performed. You can go to Amazon Glue to find some more details in there. You can go back to crawler, create more crawlers, edit the tables, schema, and more things. And if you want to run a crawler, you can select the crawler and make it running. So in that case, it will be run on demand. And if you want to provision, you can also change the frequency type. And once you run, you can refer back to the CloudWatch and you can check that CloudWatch is keeping track of all the logs that you generate, all the operations that you perform. It is reflected back in the entry. You can troubleshoot this thing as well. First, when you create a crawler, just refer back to the CloudWatch whether it is monitoring or not. If it is monitoring, then you can go ahead with all the production and the real-time scenarios. So try to create your own Glue crawler and find login sites on the CloudWatch. Keep learning and keep moving ahead. You are going to learn more in the coming lessons. Hi, welcome back friends. In this lesson, you're going to learn about Amazon Athena that allows you to perform data analysis on a dataset. So we have used a crawler to create a dataset using Amazon Glue. And now let us go into the Athena to find this dataset that is newly created database, and we can perform various operations such as running various SQL queries. So this is the dashboard for Amazon Athena. We have to select the data source and the database. It has automatically detected the Athena 101 database that has been created using Amazon Glue. We can always change the database where we want to perform the SQL queries. So just go to the tables, select the dataset, and on the right hand side, you got various options to run SQL queries. So these are the predefined queries. You can customize it whenever you want. So we go to the run query and preview table. So here we write this SQL code, select asterisk from Athena 101 dot dataset limit by 10. So it will fetch all the records from Athena 101 database, and it will show you only the top 10 result. You can go to the manage settings to change the location for the query result. We can export this query result and store it on the Amazon S3 bucket for object storage. If you want to customize it, just go to the AWS console and go through the S3 bucket, and here you can find it. You can expand it here. So we got Athena data 101 bucket already created. If you want to store the output of your queries here, you can store, or you can create a new bucket. We just need to provide the ARN for this bucket, or you can provide the link for this bucket. Here we have created this data set. We have uploaded the CSV file. Based on this, the Glue has created a database with a schema in there. So here we go through this thing. You can perform various kinds of SQL query and operations on Athena. You can run the select, you can drop table, you can add new columns, fields to the dataset, you can customize the dataset, you can perform various logical operations like filtering tables and other things here. So first we need to add this location for the query result, and if you want to allow it there. So if it is to creates a result in S3 bucket, you can always link it with other services. Based on that, it will be computed. So here, once we run this SQL query, it produces this output. The top 10 fields from the table has been selected. So you can change the value of limit. You can, if you don't want to have the limit, you want to display all the columns, you can display everything. But this would be very tedious if you have millions of fields and record. You don't want to, you want your system to be hanged. So thus you can use the limit command. You can customize this SQL query. You can run this query. You can save this query. You could write more SQL queries on this data set. And if you have multiple data set, data tables, you could join them. You can create a join, left outer, inner joins, and other joins as well using SQL queries. So try to run your SQL query on the Athena data set created using Glue, or you can use other data sources on Athena. Keep learning and keep moving ahead. Hi, welcome back friends. Here in this lesson you're going to learn about create and execute custom query on Amazon Athena, and you will also learn to save multiple queries on Athena that can be used for operations later on the same database, or you can execute it on other database and tables. So let's start with this. You already know how to write a SQL query on Athena console. So now just need to customize it. Instead of limit, just put a where clause. So we will check where a parameter or profit is greater than 20. So we can run our query based on certain conditions. We can define various conditions. So it checks the condition and produces the output. In the same way, you can have the advanced SQL queries. You can try creating with the order by. You can have a having clause. You can use the ascending, descending. You can use the procedures. You can create joins from the table. You could have multiple tables. You could use the where class. You can write an advanced SQL query. You can perform the DDL operations and other operations on SQL. So you can find the result in tabular format, and if you want to download the result, instead of storing to S3 bucket, you can go there. You can download the result and it could be created in CSV format that can be used for further analysis. So once you get the output in tabular format, you can download them. You can use it with another database. You can upload to S3, use the crawler again, and you can use for data visualization in QuickSight and much more. So there could be multiple steps. Once you have various data sources, you can run a crawler to have the analysis. It could produce a database. You can perform various queries on using Athena. Based on these queries, the output produced can be used for data visualization using QuickSight. So this is a complete flow for data science, from data preparation, modeling, cleaning to data visualization and analysis. You could also find this exported output as a JSON format. You could have advanced SQL queries. You can create each column and each row one by one. You could edit the database. You can insert new rows, anything else. And once you write an SQL query, you can have multiple queries as well. You can run various queries, produce different outputs simultaneously. And just next to the run button, you find this save as option. When you go here, you can save the query. When you save a query, you can use it on other tables as well without any requirement for remembering it or typing it again. Just provide the name of the query. Here we provide table data where profit is above 1000 and so on. You can define various parameters. You could have the query description and the query is saved. So how you can check back your queries, you can just go to the save queries options or the recent queries to find the queries that has been executed. So you go to the saved queries where you have all the queries, SQL queries that has been saved, and you can go to the recent queries that has been executed. So you can find the log on Athena itself for all the queries that has been executed, and it can be used for auditing purposes and other things. You can refer back what operations has been performed, and if you want, you can revert back. So this is how you save and create SQL queries using Athena. Try to create your own query, keep learning, and keep moving ahead.
Hello friends and welcome back. Now in this part I'm going to tell you that how you can create SD Insights cluster. So here we go. So first of all you have to select this SD Insights cluster under Analytics section. Then there will be option Create SD Insights cluster. Click there, through which you can process massive amount data using a open source framework such as Hadoop, Spark, Hive, HBase and many more things. So now I'm going to configure the basic settings first. Write the name of your cluster name. Keep in mind you must follow the rules for writing the name in Azure. Then select the cluster type. There are many different options like Spark, Hadoop, HBase, DOM. So I'm going to select this Hadoop, and these are some features which you will get. Select the subscriptions, Now write the login password because we will require it at the time of login the cluster. Okay, you can also have the option of secure cell also. Now select your resource group so that you can easily manage this service. Set the location. Now click on next. Now you have to set some storage settings for your SQL database and for primary storage. So select now I'm going to create a new storage account, SD Insights 123 ABC. So I have created a new storage account. Keep it all as default. Okay, you can also add meta storage settings here. It's optional. Now this is the summary of whole configuration we did. It will cost 205.40 Indian rupees. I have created 6 nodes, 2 heads and 4 workers. Now I'm going to submit this, and after a few minutes the deployment started, and now after a few minutes it will going to be deployed. So in this SD Insights cluster, you have many options. As I told you, Hadoop, Spark, HBase, Hive, Pig. Even there are option for notebook also, Xamplin, where you can run all the things. Okay, so it is very easy, and through SD Insights dashboard, you can also monitor the uses. You can also monitoring your nodes work, how much they are utilizing the resource. Okay, and you can also add many things into your cluster. Okay, and if you want to update your SD Insights packages like Hadoop, Spark, there's an option also there where you can change the versions of your pre-required deployments. So now go to there. It is still in deployment. Storage account is already created. Now it is creating my SD Insights cluster. As you can see, there is no green mark check is there. Now click on refresh. It is still in progress. As you can see on my screen, there are many options also, and right hand side there is additional resource, quick start tutorial for creating your Windows server, for Cosmo DB, web app, SQL database, storage account. If you're newbie in on Azure platform, you can opt this additional resources and quick start the learning. Okay, it is very comfortable platform. Let me refresh it again. It is still deploying. Hello friends and welcome back. In my previous lecture I have shown you that how you can create SD Insights cluster. Now in this part I'm going to open the SD Insights cluster, log into it, and then show you that how you can use this SD Insights. Okay, so as you can see on my screen, the deployment succeeded. Now go to the resource where we'll get your URL to access your SD cluster insights, and there are many options are there, like it's showing the status, it is running, showing the cluster type, that is 2.7 SDI. Now when you open this link, it will going to ask for sign up credentials like your username, your password. Okay, so once you log in into it, you will be access the cluster which you have created. And there are many options are available. When you're going to open this, you will find options for Hadoop, Hive, Spark, HBase. There is option cluster dashboard, cluster management interface. There are two views, Ambari home, Ambari view. Open this Ambari view. Yeah. Now you write the admin. Admin is by default, and write the password which you have given at the time of configuration. Write the password correctly. So once you open this view, Ambari view, you will going to see there are many matters will be available, and you can access and monitor all the nodes. There are totally 6 nodes. Okay, 6 nodes are there. Head and worker, 2 heads are there, 4 workers are there. D12 and D4 actually the configuration of your nodes. Now it's loading. So on the left hand side there are many technologies are there like SDFS, Yarn, MapReduce, Tej, Hive, Pig, Scoop, Uzi, Zookeeper, Ambari metrics, IOCAT, sliders, and this has a metrics like SDFS usage, data nodes live, there are 4 live and 0 dead. Then you will find SDFS links, there are 4 data nodes. Okay, you will find then memory uses, network uses, GPU uses, and the cluster load. Then this name node uptime is how much time is passed when this node is created. Then there is resource manager heap, resource manager uptime, yarn, not manager. Okay, so this is 7% used. So this is our matrix. Okay, dashboard is there. Heat maps is all there. Now click on Hive, and there's many options like Hive Meta Stores, then Hive Server, Web HCAT Server, HCAT Client, Hive Server to JDBC. This is a URL. And for Hive View, you can click on Go to View, and for debugging a Hive query, you can go to last option. Click on Dashboard, click on Heat Maps. You can also have many options. These are already installed into your cluster. Scoop, Uzi, Zookeeper. In action, you will get that you can stop all this, start all things, even restart it. There are total 6 Hive clients installed and 1 HCAT client installed. This is actually the summary of the Hive. Now click on Go to View, Hive View. Now this is a Hive view. Now write show tables. Now click on execute. So it will give the result, show the table. There is one sample table, Hive sample table is there. Now if you want to see the content of this Hive sample table, you have to use the SQL command. The database name is default, as you can see. There's a log option is there, visual explanation, and there is UI also available here. You can add different worksheet also. Now copy this table name and write select asterisk from Hive sample table. So it will give all the records of this Hive sample table, then execute it. So these are, as you can see, Hive sample table client ID, query time, market, device platform, device maker, and these are all the records, session ID. These are different columns are there. Android, Samsung, market, device platform is Android, device maker, Samsung, HTC, Motorola, state, California, Pennsylvania, Colorado, Utah, countries like United States, Europe, India. In visual explanation, you will get the visuals, and you can also insert your user defined function from here. Select extract from. Now I'm going to check. Wanted to select only records whose device platform is Android. Okay, let me copy this, paste it here again. Now write where to add the filter in your SQL command and write equal to Android. Single quotes be there, not a double quotes. Now execute it. So it will going to fetch all the records where device platform is Android. To add more filter, you can also add with and keyword. As you can see, the device platform is Android, Android, Android. So it is showing the record where the device platform is only Android. Okay. You can also add more filters by adding and write Hive sample table dot state. You can also add or if you don't want to satisfy the both condition. In this case, adding and keyword, it means that you have to satisfy the both the conditions. Okay, so now what will be going to happen, it will give the records where the device platform is equivalent to Android and the state is equal to California. Okay, now click on execute. As you can see, the device platform is Android, Android, Android. Only Android is there, and for state, only California is there. California, California, California. Okay, so this is how you can query your statement here. I hope you understand it. So for till now, keep learning and keep exploring. Hello friends and welcome back. Now in this part I am going to discuss about Stream Analytics. Stream Analytics is a fully managed serverless event processing engine that allows you to analyze data streams from your applications from your IoT device in real time. Other than these two options, from application and IoT device, there's another option, blob storage, where you have to upload a file and through which it will going to analyze it. Okay, so in this part I'm going to show you that how you create analytic job input and then how you can use this stream analytics. As you can see on my screen, this is analytics section. I have selected stream analytics. First of all, I'm going to create stream analytics job. Then I will create input source. Okay, so click here. Now write the name of your job, stream analytics test. Now choose your subscription and your resource group. I'm going to create a new resource group for it. Now choose your location, choose your hosting environment, streaming units. I'm going to select 3 units and validate it. After validation, it will going to deploy, and once your deployment process is completed, you will be able to use this stream analytics jobs. After creating our stream analytics jobs, we will going to create a storage account for our input source. Input source can be from your event hub, from your IoT hub, from your even blob storage. In this part, I'm going to use blob storage for this stream analytics. In event hub, what going to happen? It will collect the live streaming results from the application, whereas in IoT hub, it will collect live streaming's result from your IoT devices. Okay, here I'm going to use storage account for streaming purpose. This is a overview section of my job. In this query part where you will going to run your query, yeah, I have successfully created my job. Now it is ready for use. So as you can see, in this left side you will get the option input, function, query, output. This in input we will going to add our input source. Okay, now click on all services, click on storage, storage account. Now in storage account, create add new storage account, click on plus symbol. Now write the choose your resource group, choose the same resource group for which you have created your stream analytics. Now choose the name for your storage account name. It is already taken. Write something different. This name is also not available. This name is already taken. Choose the name. Yeah, this name is available. Now choose the location. Performance is, I'm going to select standard. Account kind is V2 version. General purpose V2. And access tier is chosen as hot. Okay, there is three options: access tier, hot, cool, and archive. Okay, now it will going to create a storage account, and in this storage account I will going to create a blob service, and this blob service will going to attach to our stream analytics job. Okay, so it will take time. Yes, our stream analytics account is created now. There's four services: blob, files in queue. Now click on all resources and select the resource. Click on resource group actually, and select the your resource group which you created. Stream analytics test. Here you will get two services: your job and your storage account. The stream analytics jobs and the storage account. Click on stream analytics job. Hello friends and welcome back. In my previous lecture, I have shown you that how you can create stream analytics job. Then I have shown you that how you can create your storage account for your input source of your stream analytics job. Now in this part, I am going to show you that how you can connect your source input with your stream analytics job. So here we go. So click on input. Here you will get three options: your event hub, your IoT hub, and your blob storage. Select blob storage option because I have created storage account. Okay, click on blob storage, and here you have to specify your storage account which you have created just now. Now, first of all, write the name of your source file, stream input. Select the option set. Select blob storage from your subscription. Subscription is free trial. Select your storage account which you have created. Stream analytics account 1. Okay, storage account key is automatically there. I'm going to create a container inside my storage account. So click on create new for creating your new container. The format will be JSON. Okay, and in this way you will going to connect this your source input to your stream analytics job. Okay, now the encoding is there, compression tab is there, you can select any of them. So without any wasting time, just I'm going to create a new container. Click here and write the name of your container, and here in path just write /input, so it will create a directory inside your container with name input. Okay, /input. Then you have to, if you want to specify your date format of your own choice, there's an option. Okay, now click on save. Successfully container created and input is already added. Now it is testing an input stream. Okay, in case if you want to do some changes, you have to just click there again, and yeah, connection is successfully succeeded. Okay, if you want to make some changes, click here and see any changes if required. Select your account name, click on create new, it will create it already. Okay, in this way you can, if you want to add some modification, you can modify. Okay, so this is how I have connected my input stream to this stream analytics test job. Okay, now I'm going to create other storage account, because for input you have three options like your input hub, your IoT hub, your event hub, and the blob storage. For output there's again three options: SQL database, your blob storage, and again event hub. Okay, so this is my storage account for this is storage account for input storage. Okay, now let me show you inside section of this. Now I'm going to create a new resource. Click on all services, click on storage, then click on storage account. Now click on add symbol and create your storage account for your output source. Creating a storage account is very easy. I have shown you in my previous lecture. Again, I'm going to create it. Select your resource group for this project. Write the name of your storage account, stream sync. Now select the location. Make sure the location must be same. Okay. Now performance standard. Okay. Click on create. And after validation, your storage account will be created. So this is you can review from here your subscription, your resource group, deployment model, application performance, access tier, etc. options from there. And this is how I have created another storage account for output sources. Instead of using this blob storage, you can also use your SQL database also. Now click on your resource group. Let me see that our another storage account is created or not. Okay. Now click on go to, yes, it is successfully created a newly storage account for output source stream sync 1234. Let me open its overview section. Resource group is the same, the location is also same. Okay, now click on resource group and open your resource group for stream analytics. Now there will be 3 services in which 2 storage account and 1 stream analytics job, 2 storage account, 1 for input and 1 for output. All 3 having the same location, East US. Now click on again your stream analytics job. Now under job topology, there is option input, function, query, output. If you want to add more input, you can also add more inputs. Click on input. If you want to add more, I have already added, but in case if you want to add more input, you can add from here. Input can be your IoT hub, your event hub, or blob storage. You can also add your reference input from here. Okay, so this is showing that your source type is stream and the source is from your blob storage. In future, we are going to upload the JSON file into this stream input to analyze. Okay, this is an option from where I have created stream input for my blob storage. Let me show you again. Okay, in my next lecture, I'm going to show you that how you can create output source. Hello friends and welcome back. In my previous lectures, we have discussed how you can create your stream analytics job and then create your storage account for input purposes and how you can connect your input storage account to your stream analytics job. Now in this part, I've already created actually output storage account. Now I'm going to connect this output storage to our stream analytics job. So here we go. Under job topology section, you will get option output. Then click on add and then select blob storage. Now write the name for your output alias and select the option, select blob storage from your subscriptions, select the subscription free trial, select your storage account. If you want to create a new container, you can create from here. Write container 123 and give the path pattern. In my previous lecture I have shown you that how I have added pattern for input. Just write input. Now here for output I'm going to write a path pattern output slash, and the format will be a JSON again, because we are going to give input format in JSON, and in return it will get the result into JSON format. Now click on save to connect your output source to the stream analytics job. So this is how it is. Very easy. The stream analytics is very easy. Now I have successfully created container, then attach this with my stream analytics job. It is successfully connected now. Hello friends and welcome back. Now in this part I am going to write an Azure Stream Analytics transformation query. This Azure Stream Analytics query transforms your input data streams and going to produce an output. This query are written in language like SQL. It's a subset of Transact SQL. You can call it as T-SQL. So in this part, first of all, we will use our input file which I have already created. Okay, now here we go. Click on resource group, select storage account, select first of all select your resource group, then select your storage account. For our input purpose, this is our JSON file. Okay, it contains information like city, location, its coordinate, temperatures. Okay, now select your storage account. In the storage account you will get many options, many services like blobs, your files, tables, queues, but in this part we are going to use blob service. So click on blob service, and inside it you will get the container which you have already created, the container 123. Now select the container where you are going to upload this input.json file. It is private, and this means this file will not be accessible. Now click on upload and browse your file, and once you select your file and click on upload. Okay, select the directory where your file exists. Select input.json and click on upload. If you don't want to do some advanced setting, you can just click upload. See the advanced setting also. There's two options for authentication, Azure AD user account or account key. I'm using default one. The block type is blob. The block size is 4 MB approx. Now, if it is also saying that if the file exists, then it will going to overwrite it. Okay. Now upload to a folder name input. Okay. I'm also writing the date. Now click on upload, and our upload is successfully completed. As you can see, inside our container one folder is created named input. Inside name input, another folder is created of our date one, and in this we have our JSON file for which we are going to train our stream analytics jobs and to get the output. So this is how you have to do. This is the details of the file which we have uploaded. Click on stream sync. Here we have to create a file just like in previous Unstore account. We have created a container, but inside container you have to add folder. I've added a folder name input. In this I'm going to add a folder name output, where the output file will going to reside. There's an option first of all named as output folder. Click on OK. This folder will be going to create inside your container. Okay, so in this way I have created a folder inside a container of output storage account. Now click on stream analytics test to run the query, your transformation query. It is just similar to your SQL. If you have basic knowledge of your SQL, then you can easily execute here. There's option inside job topology section, query. You can click there, or you have on dashboard option. You can add query here also. It cannot be read. It can be only read-only editor. Click on edit query to open in full screen. Now here you will get the option for saving the query, for discarding the query, for testing your query. Till now we have uploaded, as you can see on my left side, inside input there is a file stream input. In this stream input we had already attached our input.json file. In output section there is a file named stream output. This will going to store the result of this query. So write the query, select city coordinates dot longitude, latitude. As I have just added a detail of only one city of Ireland, Reykjavik, so it will going to give the result of only one country. Inside coordinate there is latitude and longitude. Now here you have to write your output alias name and the name of your input alias. Your output alias name is stream output, as mentioned on left hand side, and the name of your input alias is stream input. Okay, once you have written your transformation query, then when you are going to click on test, it will ask a file to upload. Okay, there's two options, either yes, the stream input. So there's two options, either you can upload on real time, or you can upload store your this file in your blob. So here I'm going to upload in real time. See, if I click run, it will asking for upload some sample data for the query. To add this sample query, to test the query, you have to click on the corresponding input, means your stream input file. Okay, and remove the square braces which are there, like in stream output and stream input. You have to remove these square brackets also. If it is there is nothing problem, but you can also remove this square braces. I'm going to remove this stream output and stream input. Again, if you're going to click test, it will again ask for to upload a file. First of all, I'm going to save this file, save this query, and in my next lecture I'm going to show you that the input file to be uploaded and for testing purpose. Now click here on this three dots and there is an option to upload your test data. It can be JSON file, it can be a CSV file. Choose your input.json file. Click on open. It can be Avro file also. Now it is uploaded our input file. Now you can easily test the file. Now click here. So it will going to produce a result in JSON format as we specified earlier. And there is only one record because an input I have just mentioned for only one record. You can download this result and open this stream output.json in your favorite editor. So this is how you can execute your stream analytics job and how to upload your input stream and how to get the results. I hope you understand. This is the inside view. As you can see, the name of file stream output.json is there, and the result which I have shown you here, it is also the same as in my editor. So here we have created three things: two storage account, one stream analytics jobs, one storage account for input and other for output. So this is all about stream analytics. I hope you understand. So till now, keep learning and keep exploring.